So again, today that's the question for you people, bachcho. So how you would have solved it, or how you will solve this question? So see, just take x as 0. What you get in numerator? This is 0 minus 0 upon 0, 0 plus r. So it should be 0, but the value is given to be minus 1 by 12. So that simply means, if at all it has to take some finite non-zero value, the form should be 0 by, it should be an indeterminate form, and since numerator is 0 for sure, denominator must be 0. So therefore, just by looking at it, we can say r is 0 for sure. So one thing is done. Now we have to find a value for p and q. So let's start. We will say, okay, limit as x approaches 0. See, here I am looking at it as sine A minus sine B. So why not to apply the formula? So 2 times cos A plus B. So sine x plus x by 2 into sine A minus B, sine x minus x by 2 upon p x cube plus q times x raised to power 5. Now, as x approaches 0, this approaches 0 and cos 0 is 1. See, I again and again repeat this thing. If you have some factor within the limit expression which is not contributing in 0 by 0 form, so just remove it. Put the limit and take it out. So as x approaches 0, this is cos 0, which is 1. So I am taking out, removing it, taking 2 out. So limit x tends to 0. Now this is sine t, because this is approaching 0 as x approaches 0. So to get sine t by t, I will say, okay, let us multiply and divide by this. So this is t for me. So sine x minus x by 2. So this is t. So since I divided by t, I have to balance it. I have to multiply also by t, and in denominator we already had this term, so we can't miss it, isn't that? Now what about this one? Can we write it 1? Of course. So this is nothing but 1, so remove this one also. So this is 2 times limit as x approaches 0. So what are we left with? So we are left with this thing in that numerator, which is sine x minus x by 2 times px cube plus q times x raised to power 5. 2 and 2 gets cancelled. So limit as x approaches 0. See, now I will suggest you, though you can go for L'Hospital rule also, but I never suggest that. So what I will suggest you is to use series expansion for sine, which is x minus x cube by 3 factorial plus x raised to power 5 by. See, series expansion is very crucial, but you all should remember it by heart. Now this is p times x cube plus q times x raised to power 5, and now I am writing that the limiting values given is minus 1 by 12. Now, x and x gets cancelled. Okay, now one more very important thing. If you have 0 by 0 form, in both numerator and denominator, you have polynomial 0 by 0 form, then the power of least degree term in both numerator and denominator must match so as to get non-zero finite value. I am repeating, in 0 by 0 form, if you have polynomial in both numerator and denominator, then to get non-zero finite value, the least degree terms power in numerator and denominator should match. Okay, so that means the least degree term should be x cube here, which is x cube here, and here also it's x cube, so it's matching. Now take x cube common, so that means now you are at the position where you will get, where we will get the non-zero finite value. Okay, this is what we get. Take x cube common, p plus qx squared, that's it, x cube. See, since the least degree terms power in both numerator and denominator same, 3 and 3, we will get something which is what? Which is your non-zero finite value. Now this is equal to minus 1 by 12. Now as x approaches 0, every other term except the first term in both numerator and denominator will go to 0. So that means q has no role to play whatsoever. Q can be any number, including 0. It can be any real number, doesn't make any difference. So minus 1 by 6p is equal to minus 1 by 12. So therefore p must be 2. So what we got? We got r as 0, p must be 2, and according to me q can be any real number. I think all of you will agree with me in this, bachcho.